All right, everybody online can hear me? Let's assume that's a yes. All right. Oh, interesting development with Hearthstone for those who've been watching me live stream. So on Friday, right now is BlizzCon, so the big conference from Blizzard. They made a change to one of the cards. So we're building cards here to make it a little bit more expensive, so that cheater paladin deck stops working. Stops working like it would. So the next day I hit legend. So at least everything I've been saying about this deck just not being fair is they actually call it cheese paladin. It's just stupid. Turn 4, you're just dead. What's this? Oh, they're announcing a new expansion for that, and then yesterday was about World of Warcraft stuff.
저 금전 광란 떴습니다. 근데 속사 손잡입니다.
I'm getting some stuff in other languages here. I think he just realized he's not muted.
이게 뭐 유언도 아니고.
All right. Yeah, I think they may have gave some announcement about Overwatch too, but I don't think like any details. My understanding is that the earliest it's coming out is like late next year or something. So you'll be waiting a while. All right. So homework for today was we wrote some code in class last time. And then several classes ago, we wrote some code that allows us to hold information about cards. All right, so last time we wrote some code that allows you to bring JSON information into your project and for these cards. And then we already have these objects that allow us to store information about cards. So our goal was to fill an array up of minions, specifically minions. If you remember in class last time, we'll go back to the code here in a second. I went through and I counted the number of minions. So I created an array of just the exact number of things. Not the best way of going about it, but we just happen to know that that's accurate. And then, we want to fill it up with minions with instances of Hearthstone cards that we had already written using the constructor that we'd already written that takes in a name, a cost, an attack, and defense. So test the code by displaying all the cards. So our cards already know how to display themselves. All right, so if I go into Eclipse here, just to review what we did last time, we are reading stuff in from our Hearthstone JSON thing, and we built our own URL reader thing. Then we went ahead and we got our JSON object, which does the parsing. So it went through that and parsed through the details. That does all the magic for it. And then I created this array called the minions that's of type Hearthstone card. And it's specifically going to hold 1,924 of them, which happens to be the exact number of cards that are minions that you'll run into. All right. So now, as you go through your JSON array, so remember the data we're dealing with is a collection of JSON objects. Question? Yeah, but I would say anytime you hard code a number of elements is probably a bad idea. I'll show you an alternative to it today. Like if you want something more flexible, we'll look at something called an ArrayList. I just didn't want to introduce too many new things. But yeah, if you want to just say, hey, here's 5,000 buckets for holding stuff, I'll just keep track of how many things they actually put in there or something like that. Yeah.
So there's this thing in the Eclipse that keeps that happening to me, and pretty much the cursor turns into like a blinking black box. Like whenever I type it, when it goes over.
I'm guessing you keep hitting the key is I think numlock on your keyboard or insert. One of the two. Do you have a key? You either have a key that says numlock or a key that says insert.
Oh yeah, it's insert.
Yep.
Okay, thanks guys. I kept having to like save it and reopen it so it go
For those of you online who didn't hear that, if you have this issue, if you're ever in Eclipse and all of a sudden it gives you like a black block, and whenever you type, it deletes stuff, that has put your keyboard is in insert mode. So just find the insert key and press it again, and that'll toggle that off. You probably accidentally hit it with a pinky or something.
It toggles insert and with likes.
Although you don't commonly find it on a lot of laptop keyboards anymore. It's just one of those things that's been there since day one of day one of keyboards. All right, so we have our collection of minions that we're going to use to store these particular minions. We have this array that's going to go through, so I asked a question here. I said, if object is an instance of JSON array, so last time we introduced this new keyword called instance of, which is a Boolean operator that allows us to detect whether this dude is an instance of this dude. So if I'm inside this if statement, I must be looking at a JSON array. So I'll go ahead and I converted it to a JSON array here, so I would have access to all the JSON array functions conveniently. I'll keep track of a count. The count is what I used last time to know how many minions I had. So I go through my entire array. I go ahead and get an individual card. This is the data associated with an individual card. I'm asking, does this card contain the key cost and name? If yes, does the card contain type? If yes, get the type, and is it equal to minion? So I'm only in here. I'm only here if this is a minion card. That should have, because all minions have an attack and a defense and a cost and a name. So I'm only in here if I have a minion card, okay? Because I mentioned there's some other kinds of cards that wouldn't be compatible with our current design for our Hearthstone card. If you look at our Hearthstone card thing here, we take in a cost, attack, a defense, and a name. Go ahead.
So if you were to put in, if you were to append something to an array in that if statement, the last one there, and you put it as the contents of the card data, would it only like put the contents of that's inside the if statement, or would it do the entire contents?
I don't know what you're asking.
So you see after the if statement, like where the system.out that println is?
Yeah, like in here.
Yeah, so after if statement, if you were to append something from card data onto, let's say, like a string or an array, would it only put the stuff that's inside the if statement, like the cost and the name?
Well, these are unrelated. I mean, card data whole is an object.
Yeah.
It's a JSON object. So, I mean, if you wanted to append a piece of information, you would have to say something like card data.get, the thing you wanted to do, because
Okay.
you'd be concatenating with strings.
All right.
All right, so last time we printed out our example of our name, our cost, our attack, and our health. And if I want here, I can do something like this. Put a little hyphen like that. Just to make it look a little cleaner on the screen when we go to type this out. I'll change all these to just prints, but I'll make the very last one a println, which will kick it down. So this will have the whole card on one line, is the idea here, so we can view it a little bit better. And then we'll start building our objects. All right, so anywhere that I saw a 1924, so interesting. Didn't that change? Oh no, it's the same. So here's the name of the card, the cost, the health, the defense. So we're seeing the different pieces of information. All right, now if we look at our Hearthstone card, this thing we've previously written, we need a string, an int, and an int in order to build a Hearthstone card. Those are the 4 pieces of information that we need. So I need to extract that information in here. Here's the 4 pieces of information I have. Card data.get name, for example. So I can say string name is equal to that. I can say int cost is equal to integer.parseInt card data.get cost. That'll convert that thing into a integer. Oh. You can either typecast it to a string or just call toString on it. So you could have either done, I think that'll do it. So that'll get you the string version of this guy, because he technically comes out as a generic object because we don't know what kind of value card data holds. The data associated with cost could be another JSON object, right? Could be a JSON array, or it could be a flat value like a string or an int or something like that. Go ahead. Well, you can, but you then have to go into your constructor and change what it takes. Well, realistically, we're going to make it even a better idea here in a second. Did you had your constructor just taking a single object? Okay, we're probably going to have it taking a single object today, and we'll have the constructor actually do the JSON parsing. We'll have it pull the pieces out. Because right now, if we look at driver, we're going to start saying this is getting a little bit scary looking, right? So we're going to try to clean this up a little bit, but let's get it working first. All right, so we'll get the cost. We'll get the attack. We'll get the health. All right. This guy's the same thing. It is a string, but we have to let it know it's a string. Hearthstone card takes name, cost, attack, defense. So we'll go ahead and say the minions at bucket count is equal to a new Hearthstone card, passing it the name, cost, attack, defense. The cost, the attack, and the health. Okay, and then if we want, we can go ahead and say the minions at bucket count dot display. The minions so this is adding that minion card to our collection of minions, and then we're proving it by going ahead and just displaying the minion we just added. And then we're incrementing count. So the first time through count is 0 because the first card we put at bucket 0, then we put it at bucket 1, then we put it at bucket 2, so on and so forth. So I'll go ahead and run this, and now we should have our display based on the actual minions themselves. Long cannot be cast to a string. Who is a long? One of these guys came back as a long. Well, multiple of them probably came back as a long. This will probably fix it. So rather than cast it to a string, I'll just call the toString on it. All right, so here's an example of plant has a cost of 1, an attack of 1, a defense of 1. Scroll up some, we got stasis elemental, cost of 4, attack 3, defense 5, so on and so forth. All right, so we have our collection of Fallout slime, cost 1, attack 2, defense 2. Yep, that's where we're going. Yeah, if you look ahead on the notes, you'll see that one of the things we're dealing with in here is searching and sorting and things like that. We're just giving ourselves kind of a fun source to do the searching and sorting on. Yeah, what he's saying is, hey, wouldn't it be handy to have all of the 1 cost minions and all of the 2 cost minions and all of the 3 cost minions, or maybe you want to sort it on the attack. You know, I need, because, sometimes you have cards that have a whole lot of attack, but have very little health. A card that comes to mind is this card that has 9 attack and 1 health. Easy enough to kill as long as you have something and do one damage to it, but otherwise it can hurt you pretty bad. Okay, so I think that would accomplish the homework assignment. Read in all the cards. All right, so let's take a little bit of a jog here, and let's talk about one issue we have here. That's a historic computer science issue, and that's this guy right here. We're gonna say that if you ever hard code the value in this for the size of an array, unless it's something like I need to store 10 numbers. So I'm going to build an array capable of holding 10 things, something like that. But in this case, we're dealing with dynamic data. And I mentioned before that for all I know, this particular, and actually we might know here in a couple of weeks, because they're releasing a new set of Hearthstone cards, a new expansion. So presumably this JSON should give us an expanded list of cards, assuming it's being monitored somewhere, updated, things like that. But the idea would be there's going to be some additional minions. So in 2 weeks, 1,924 is no longer the actual number of minions we're reading in. Hopefully it's not fewer, right? If it's fewer, then I might run into problems. Well, actually, if it's fewer, I probably wouldn't run into problems because I would have enough room, but it's likely going to be more. Maybe there's going to be 1,950 minions. So when I go to add minion to bucket 1,924, which is 1 off the end of the array, it's going to scream at me. And we can see that if I pretend like I didn't notice and I actually make that array 1,923 buckets long, and then I run this, we're going to get a crash right there near the end saying, hey, you walked off the end of the array. You built the array to hold 1,923 things. So when I ran into the thing at 1,900, when I ran into the 1,924th thing, I had no place to put it. All right, so we kind of have a chicken or the egg type problem here where we're trying to create a storage location for our stuff, yet we don't actually know how much stuff we're going to run into. Does that make sense? So we might want a little bit more elastic storage location. So we're going to say problem with arrays. I'm going to put a little note here. Arrays are not a bad thing. They should be used when they are the right tool for the job. So something that we should consider with arrays is arrays are inflexible in terms of their size. When you create them, they remain that size forever. Okay? Alternatives. In the 300 class, we start talking about other data structures like linked lists and stacks and queues where we write our own. These things actually already exist in Java, but we're going to pretend like they don't for right now because we have an alternative to that. That's a pretty common thing that you'll see in online examples and stuff. So right now we're going to list our alternative as something called an array list. So an array list is basically an array that can grow or shrink in size as needed. Make sense? So that's what this tool is. So we're going to say we ran over to Home Depot, we bought an array list. All right, so I got this array list, we took it out of the package. Now I got to say, I'm going to use this guy. So let's go into our code. And we're going to say we want to create an array list of Hearthstone cards. We'll call this guy the minions. And it's going to be a new array list of type Hearthstone card. And this is probably a java.util. So we're bringing in another library, ArrayList, which lives in java.util. So notice here that we're going to go ahead and replace our array implementation of the minions with an array list implementation of the minions. This syntax right here in Java is something called generics. I don't need it. I can leave this off and this will be just fine. And it's actually related to something that you saw in this assignment. As of right now, this array list will hold generic objects because we know that anything that is an object will ultimately be an instance of object. We talked about that last class, right? But we happen to know that in this particular situation, my array list is holding more specialized data than just a generic plain Jane object. It's actually going to hold Hearthstone cards. Now, if I say right now, if I say the minions dot add, for instance, see this little drop down here? It's expecting me to pass it an object because that's what this array list knows how to hold by default. But if I put my Hearthstone card thing back in there, I'm now effectively delivering a message to Java saying, you know what? This array list is actually built specifically for holding these kinds of things, not generic objects. So now if I say the minions dot add, notice it now takes a Hearthstone card as a parameter. So the benefit for us is less about putting something in, and it's more when you take it out. When you get something out of there, it will now come out as a Hearthstone card rather than a generic object that we happen to know is a Hearthstone card and would have to then typecast it into a Hearthstone card. Okay, so instead of coming out in costume where we don't necessarily know what it is, it's kind of like that, was that singing competition where they were dressed in like the doll head things? You know what I'm talking about? Masked Singer, that thing. Yeah, we don't know who the actual singer is under the hood, but it's a real singer. It's not whoever the mask is. So if we use a normal array list, it'll come out as this masked thing where it actually is a real thing under the hood, but we won't be able to identify it without making some guesses. But in our case here, we're the programmer. We know that we're going to be storing Hearthstone cards in here. So we might as well gain the convenience of saying, look, when you give me something from this collection, go ahead and give it to me as a Hearthstone card, rather than giving it to me as an object that I then have to turn into a Hearthstone card. Just saving me a step. Okay. So this is going to be our upgrade to our array collection. And this guy no longer requires me to know how many elements I'm going to store. So now this guy's going to behave like lists did in Python, where we can just start adding crap to it. This wasn't a problem we ran into in Python because Python's arrays, their list data type was elastic. It allowed us to remove things, add things, and potentially bad stuff was happening under the hood in terms of memory management, but it wasn't our problem. Somebody else was managing it for us. Okay? So We have replaced our collection type now. Down here, notice it's no longer does it like me to say this. Now what it wants me to do is it wants me to say the minions dot add. And I'm adding a new Hearthstone card. So I'm adding something to this collection. What am I adding? I'm adding a new Hearthstone card. Now, if I want to get the guy I just added, I can say get count and tell that guy to display. Does that make sense? Now, what's nice here is I actually do not need to keep track of how many things I ran into now. We no longer care. And let me show you what I mean by that. I can go ahead and I can get rid of my counter here. It doesn't matter how many I ran into. Every time I run into one, I'll just add it to my collection. So by removing that variable there, I no longer increment each time, but this guy right here is no longer going to work. All right. So I have a couple of different things I can do. So if I go to the minions, I press dot. It might have something like last. No. No. So we're going to still use get. And what are we going to get? We're going to get the minions dot size -1. And call that guy's display method. The minions dot size is kind of like the length of a list in Python. This is the number of elements that are in this array list. The last legal element in there is the size -1, because the first legal one is bucket 0. So this is saying, get me the minion that lives at the end of my array list. That is the dude I just added. And go ahead and tell that guy to display. Similarly, I could have done this. I could have said Hearthstone card temp is equal to this guy. Add temp, and then tell temp to display. That'll accomplish the same thing without having to go and look it up again. Put it into a variable, add the variable to the your array list, and then use the variable to display the thing you just added to your array list. Both of them will accomplish the same output. Now, instead of count here, I'll go ahead and say the minions dot size. That's the number of things I added to that collection. Make sense? So I'll run this. We're going to get the same output as we got before. Just our means for doing this was a little different. Notice I still got 1,924. I still get all the same output. I still created all the same objects. But now I didn't have to know beforehand how many minions I was going to bump into. Now I can just say, hey, look, here's a collection. It's a bottomless bag as far as we're concerned. I run into a minion, build it, excuse me, build it, put it into the collection. All right. Questions on that? All right. So for right now, let me go ahead and just so you have this version of the code. What homework was this? Updated for homework number 6 solution. Commit that, push it. So you'll have, if you want to go in and look at driver for this version of homework 6, because I'm going to make some changes from this point forward, you'll have that snapshot. Okay. So now we're probably getting into a place where we're going to say, you know what? This is starting to look a little bit ugly out here in Maine. Now, that doesn't mean that this code's not going to go somewhere. We're right back to that argument of, you know, the procedural telephone versus the object-oriented telephone, where you have this pile of wires. what we see here is starting to look like a little bit of a pile of wires. Looking a little messy, and we know now that this guy is doing all the stuff we wanted to do, but I'm not sure we need to see those details. So if we can kind of take this stuff and hide it someplace else, that might be nice. All right, so we already have this URL reader thing. What we're going to go ahead and do is we're going to build a class called Card Parser. Okay. I'll go in here, we'll right click, we're going to say a new class. We're going to call this guy Card Parser. And this guy will just keep track of initially our URL string. So we'll say private string URL string. Then we'll have our public card parser string URL string. This .url string is equal to URL string. All right, let's just start with that for right now. We have a basic little class that I can build by passing it a URL string. So back here in driver, what I want to do is I want to say, I want to create a card parser, CP. This guy's going to be a new card parser. And I'm going to pass it that string. Okay. Now I'm going to take the rest of this crap. We're going to go into our card parser. And for right now, I'm going to put it all in here, but we're going to adjust it a little bit. So notice that it went ahead and automatically imported my JSON array, JSON object, JSON value stuff. So my URL reader is going to be this URL string. I'm going to get some of these things out. We'll go ahead and we'll still parse our stuff. Get our collection. Now I'm actually going to make this collection something that belongs to my card parser. So private ArrayList, actually, I already copied it. Copy ArrayList called the minions. So inside my constructor, I'll just initialize my minions to be a new array list of type Hearthstone card. It's empty, nothing in it initially. I could have initialized it up here if I wanted to, but good programming practice says define the fields, the things we want to remember up here, initialize them to their starting values down here. Make some sense? All right, so here, if I want to order it a little cleaner, I'll go ahead and say, here's my fields. So I'll just say initialize fields like this. Then we'll go ahead and we'll create our URL reader. And this is going to be a local variable that lives and dies with this constructor. I'll go ahead and get my object just like we did before. I'll go ahead and read through, assuming this thing's an type JSON array. I'll go through here, do the same stuff I did before. I'm not going to display it here, though. I'm just going to add it to my minions. Similarly, we'll get rid of that. All right, so all the logic we did before is now in the constructor for card parser. Now, after card parser is done, we're going to go ahead and we're going to create a public void show minions method. And the job of the show minions method will be to display all the minions. So for int I is equal to 0, I is less than this dot the minions dot size, I plus plus, this dot the minions dot get I dot display. So that will go through after I've constructed a card parser. he will go ahead and do all the magic of filling out that array or filling out that array list. And then I can ask that card parser to go ahead and show me the minions, and he'll prove what he did, showing me all the minions. Come out to driver here. There's my instance of card parser. I'll just say cp dot, didn't I make it public? I have too many closing things here. Closes that, closes that, closes that, closes. Oh, that looks right. Get rid of these extra things here that we're not using. Yeah, there it is. I just had to save the file. So there's my cp.showMinions. So now main looks a lot cleaner, right? Run this, should get the same output we got before. So there's our show minions. If I don't tell it to show the minions and I just run it, it's still gonna, here, we'll put a little system.out.println done here. We're gonna be able to tell it still went and hit that site and read in all those things, because it's gonna take a second for us to get that done. All right, we just happen to not tell our card parser to display the minions that it found. All right, so we're going to say this looks a lot cleaner now because we want main to kind of feel like it's our conductor. Okay, main is saying, here's what our application does. All programs begin and end with main. So we're going to start off by creating a card parser around this website that we happen to know has our stuff in the right format, whatever. Okay, because my card parser thing that we created here is, you know, a very proprietary piece of software that knows exactly how to read something that was formatted from the JSON that we got from that site. All right, so really all we've done here is just hidden those wires inside the wall. Go ahead. Yep, that's what we're going to do when we do the Android version of this. We'll pull the pictures. That's kind of why I picked this. So yeah, I realize this is a game I play, but do you also see how it's practical from the perspective of, hey, this is a real problem. We have a real data set. You don't have to know what the game is or anything like that, but now we can keep expanding it and see how do you do actual things, right? Things that you might want to do. I don't know. We'll have to look at, you're talking about for the images? Yeah, I didn't look at what the images look like. Hold on, we can tell pretty quickly. I just do, let's do print, sorry. Actually, let's do it inside of the minion type, just so we have fewer of them to look at. System.out.println card data. It's actually calling card data's .toString method, which shows us the JSON. So let's just explore that real quick. I'll tell it not to show me my nicely formatted minion. So what I'll see is just JSON, 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 and we'll scroll through one of them and just see what does the picture information look like. My guess is it'll be a URL, another place to go to read in image information. Haven't seen it yet. Do you know what the field is called? Called like IMG or image or? Unless we do it off of the ID. Let me just copy that. It's possible that that ID is like a standardized thing. Or maybe you have to get it from Hearthstone's direct API. Yeah. So we'd have to look at what the JSON this guy gives me is, but he's going to give me, I'm guessing, copy image address. He'll give me that. The full URL to where this PNG lives so that I can then open up another thread to go and download that image and show it on my Android screen or something like that. Yeah, totally doable, but the concept, what you're saying is I need the data to do it.
Yeah.
So one way or another, I need to get the data. So whether that the JSON we're already working with has the image URL in it, or it just gives me some unique ID that I can then go and talk to another source of information, like Hearthstone's library, and say, hey, here's the card ID that I have. I'd like to get some more information about this guy. And it would then give me, you know, among other things, the image URL. And then I can say, okay, now I have the image URL. So I want to get that image. Downloading the data off the internet, then I can actually show it. Make sense? All right. And actually, an interesting thing we can look at here real quick is I might be able to do card data dot, so just like a dot keys. Now let's see what key set looks like. I'm guessing toString probably shows me that guy instead of memory addresses. Yep. So these are the actual keys that it has available. Collectible, cost set, artist, health mechanics, DBFID, ID. So notice that not all of them have all the different pieces of information. I'm guessing that anything that has an artist also has an ID, would be my guess. Okay. All right, so now we're going to go ahead and we're going to give ourselves a, actually, let's do it this way. Sort smallest, let's call it lowest cost to highest cost. This method's job is to take our array list of minions and rearrange it so that it is in the order of cards with the lowest cost first and cards with the highest cost last. Note this dot the minions dot get 3 dot get cost. I think we wrote that. Just make sure we didn't. So I'm going to go ahead and give myself the cost. Cost is a private field. I'm going to say public int get cost This guy will return this dot cost, the cost of an individual card. So now we can ask a Hearthstone card, give me your cost. Well, we can ask an individual card, what's your cost? But our goal here is to say, I have 1,900 cards, and I want the cards with the smallest cost to go first, and the cards with the highest cost to go second. All right. Now, we're going to be talking about sorting algorithms. But for a starting point, you don't have access to any sorting algorithms. So you will need to cobble together your own algorithm for getting this array list sorted. I think I'm going to leave it like that so we get some interesting approaches to it. I'll just say out loud one possible approach just so you kind of have an idea. One thing you could do is you could create a brand new array list with nothing in it. Then you can go through the original array list, find the position of the smallest cost card, noticing that there's going to be several cards that are all cost 1. So it doesn't matter which of those you grab first, right? But find the position of the smallest cost card. Remove that from the original, add it to the new one. Okay? So this dot the minions dot remove index. This will give you the cost of card number 3. Note this dot the minions dot remove 3 will remove the card that used to be at bucket 3. All right, so what I was saying there is go through, find the first smallest card. Once you have the position of that, remove it, put it into the new array list. Then find the smallest card again. Once you find that, remove it, put it into the new array list. Then find the smallest card again, so on and so forth, until you run out of crap, until the size of the original guy is 0. That makes sense? Okay, so you can take a different approach if you want, but that's one, let's call that the brute force approach, where we're leveraging the computer's processing power to say, look, we got 1,900 plus things to look at, no problem. I'll find the smallest, then the next smallest, and the next smallest, and the 1,924th smallest, add it to my new array list, ultimately copy everything back over to the original. Poof, sorted with a lot of hard work. All right, make some sense? All right, so implement sort lowest cost to highest cost is the homework assignment. Current code. Yeah, whatever. I'll get that formatted. All right, I'll put that up on Blackboard. Questions, comments, concerns, bribes? All right, I'll see everybody on Wednesday, and I'll push this here. Updated for start of, what's this, homework 7 is the next one? Okay, it's up there.